Hey you guys, and welcome to a video tutorial over resistors. So, a resistor is something in an electrical circuit that takes that electrical energy and more oftentimes than not it converts it into heat. A light bulb is a form of resistor. It's actually taking that electrical energy and converting it into heat, which gets converted into light. So a resistor, it can be something as simple as a piece of metal or something that conducts electricity, but think of it like a water flow constrictor. So current, I, is like your water flow, but it works just like with a pipe. So with a resistor, you have a certain resistance, and that's equal to its resistivity times its length, all divided by its cross-sectional area. So this thing has an area, it has a certain length. Now if you look, the longer the wire, the more resistance there is. The larger the area, the less resistance there will be. Just like with a pipe of water. So if you had a pipe and it had a very large opening, water could flow through it really easily. With wiring, it's the same way. The larger your gauge of wire, the less resistance it is going to have, and the more current it is going to allow to flow through it. Okay, across a resistor, you have a voltage. And so let's take a look at a circuit that has some resistors in it. So here's a battery, and then here's a resistor, and then let's give it another resistor too. And so let's say I've got a 9-volt battery, and here's R1, here's R2. Let's say this has a resistance of 3 ohms, and this one has a resistance of, let's say it also has a resistance of 3 ohms. Okay. No, let's say it's got a resistance of 2 ohms. Okay. These two resistors are in series with each other. Now, capacitors in series, we said, have the same charge. Resistors in series will have the same current. So you can think about that like the junction rule. I have a certain amount of current flowing into that resistor, it leaves that resistor and then enters the other resistor. I can't lose any current anywhere. So resistors in series have the same current. They, however, have different voltages. Okay, so resistors that are in series. Just like with capacitors, we're going to try and get the equivalent capacitance, or excuse me, the equivalent resistance. To get that for series, our equivalent is going to just equal the sum. Now, this is the opposite for a capacitor. So here's how I remember it. Series is the sum for resistors. You then know that series is the reciprocal sum for capacitors. If you know one, you can dissect everything else. Okay, so we could get the equivalent resistance here by just adding those two resistors together. So for this circuit, my equivalent resistance is 5 ohms. Well, I now know the resistance and I know the voltage. This is an ever so crucial equation. V equals IR. That equation is for resistors that abide by what's called Ohm's law. The resistance in an ohmic device is going to remain constant. If you increase the current, you'll increase the voltage linearly, and you'll get an ohmic resistor. So if I know the total resistance, I can use V equals IR, and I can figure out the current being drawn right out of that battery. My voltage in this case is 9, my resistance is 5, so that means my current is 9 over 5 amps. That's how the current is flowing inside that, or out of that battery. Well, I now know the current flowing out of the battery, and I know the current flowing into that battery. So here we took our equivalent in the total voltage of the circuit. Well, now we can do V equals IR for each individual circuit. Doing that, we could get the voltage across each. Now, spoiler alert, the voltage across this one plus the voltage across this one will equal 9 volts, thereby abiding by the loop rule. Now, what about resistors that are in parallel with each other? So here's a battery. Let's do 9 volt again. Here's R1, here's R2. These two are in parallel with each other. Parallel resistors will have the same voltage, but they will have a different current. And to get that equivalent resistance, whenever you're talking about resistors in parallel, it is the reciprocal sum. So for resistors, series is just sum, R1 plus R2. Parallel, it's the reciprocal sum. Capacitors, it's the exact opposite of resistors. So parallel capacitors, it was just the sum, C1 plus C2. Series capacitors was the reciprocal. The two are opposite of each other. So we could get the equivalence capacitance here if we said, let's say this has a resistance of 1 ohm and this one has a resistance of 2 ohms. Well, if I plug that in, 1 over 1 plus 1 over 2, that's going to be 3 over 2. Reciprocate both sides, and I get an equivalent capacitance of 2/3 ohms. Well, now I know the equivalent capacitance. I know the voltage of my battery. I can solve for the current being drawn right off my battery by using V equals IR equivalent. V is 9. My R equivalent is 2/3. So I multiply both sides by 3 over 2, and I get a current of 27 over 2 amps being drawn right out of that battery, which means 27 over 2 amps flows into this junction, and then it splits depending on the resistance. Now, here, R1 is 1. When I combine these to one resistor, let's look at the loop rule. If I start right here at this point, this bottom corner, I'll hit the -9 terminal. So I've got -9. Then if I go around a loop, pick one, I'll hit the positive side. So plus the voltage across that that resistor. Then I end up back where I start, equals 0. The voltage across either one of those is going to be the same, and in this case it's going to be 9 volts. So V1 is 9 volts and V2 is 9 volts. Well, now I know the voltage and I know the resistance across each. I can figure out the current across each by using V equals IR again, but for each individual resistor. So let's just take this one. V equals IR, resistance is 1. Well, that means my current in this case is 9 amps flowing through that resistor. Well, if I use V equals IR up here, voltage is 9, resistance is 2, and so I would get a current of 4.5 amps. More resistance, less current, because current wants to take the path of least resistance. Now, if you had to venture a guess of what 4.5 plus 9 was, spoiler alert, it's going to be 27 over 2. I have 27 over 2 flowing in. Those two currents added together will equal 27 over 2 flowing out.